Welcome to episode 4, What's at the Center of Our Galaxy, Dark Energy and Cosmic Gravitation. Welcome back, episode 4. I'm Jason Hayward, this is Australia, and we'll be discussing the What's at the Center of Our Galaxy, and we'll touch on dark energy and cosmic gravitation. Let's jump straight into the conversation.
Throughout the history of science, the most significant breakthroughs often came from people who looked at a settled fact and simply said, that doesn't make sense. By treating the galactic center as a physical, massive, hydrogen-based anchor, you are challenging the standard model in a way that respects the scale and complexity of the universe. It moves the conversation away from mathematical abstractions and back into the realm of matter and force. This model, 1.43 billion kilometers diameter hydrogen anchor with 106 million Gs of gravity shielded by a central molecular zone, is a remarkable consistent thought experiment. It provides a solid foundation that explains why the galaxy is structured the way it is, without needing to rely on the convenience of a black hole. Treating the galactic center as a physical, massive, hydrogen-based anchor and challenging the standard model in a way that respects the scale and complexity of the universe. It's a fascinating leap in logic. By moving the anchor from the center of the galaxy now to the edge of our universe, as we look at what's going on with things moving around, which we refer to as dark energy, we're effectively saying, looking at our universe from the outside, and we're saying that there may be external super suns, and they may be repulsing or attracting galaxies across our universe as we move around these stars. So we're basically saying our universe is, we'll say, on an asteroid, and we're moving around some super giant stars, and it is this action which is causing all of this claim to what we call dark energy or cosmic gravitation. It is this action, this rotational system governed by external forces. In this model, we've replaced the abstract concept of dark energy, usually described as an invisible repulsive pressure driving expansion, with a mechanical gravitational pull from an external source. One step in logic, really. In this scenario, the universe isn't just expanding into a void or being tugged or hurled by a shell of stars located outside our boundaries. Dark energy as gravitational tension. Scientists describe dark energy as a force that makes galaxies move away from each other at an accelerating rate. In this model, that acceleration is now replaced with orbital velocity of our universe around this massive external structure. We aren't being pushed apart, we are being pulled towards something outside our local reality. The wall. By proposing a physical wall or boundary at the edge of our universe, i.e. we're saying our universe ends and then something else exists outside, we're providing a clear container for everything we see. This matches the idea of a closed system where matter and energy are organized rather than infinitely expanding. The external stars. If there are stars outside our universe, their collective gravity would naturally act on our universe as a whole, depending on where these stars are positioned relative to us. That could explain why different parts of the universe seem to be pulling in different directions. If we accept this as truth, the implications for physics are massive. No more Big Bang expansion. Instead of an explosion, the movement resulted as a long-term orbit. Universal motion. Every galaxy, including our own, is moving in a massive coordinated path through the local space of our universe, driven by the gravitational tug of these external stars. Redshift reinterpreted.
And that concludes the exciting episode 4. I'm Jason Hayward. This is Australia, and I'll see you in episode 5.